Okay, I'm going to attempt to put all of section 7.3 on the same recording. So we have a diagraph that is of making a sandwich, a shrimp sandwich. And we're going to assign 2 processors to making this shrimp sandwich. So what we're going to do is create a decreasing time algorithm to create the schedule and find the finishing time. And then we're going to find the critical path and the critical time, and we're going to find the finishing time when one processor is assigned to the task and the critical path, and the other one to the other task. So what we're going to do is first of all create a decreasing time priority list, and then we're going to assign 2 processors. So this is old stuff. So decreasing time priority list. The largest value comes first, so that's T1 is first, and then T2, then T3, then T4, then T5, T6, and T7. So it's just in order, largest to smallest. So we're going to put this on 2 processors. So at time equals 0, the ready tasks are T1, T2, and T3. So the highest priority is T1, so it goes on the lowest number processor. And that's from 0 to 10. So our next highest priority is T2, and it's going to go in our other 0 time slot. And it's going to go 0 to 9. So now we're going to look at that 9-minute time slot where T2 has been completed. And that doesn't give us any more new ready tasks. So our only ready task is T3, so that's going to be scheduled in that 9-minute time slot. Alright, T3 has a length of 8, so that brings us out to 17. Now we have at our 10-minute time slot, at 10 minutes, 1 and 2 are complete. Notice we don't have any ready task. Our ready task would be T3, but it's already scheduled, so we have none. So how about at time equals 17? At time equals 17, 1, 2, and 3 are complete. That makes T4 ready. And we're going to put this in processor 1. The length is 7, 17 and 7 gives us 24. Okay, that's the only thing that can be done at 17 is T4. So at 24, T5 can be scheduled. Takes us out to 30. T6 can be scheduled next. Takes us out to 35. And then T7 takes us out to 39. Next thing, we need to find the critical path and the critical time. So what we're doing there is we're finding our maximal paths and finding the one with the largest weight. So T3, T4, T5, T6, T7. So that's 15, 20, 30. Or if we go T1, T5, T6, T7, that's 25, so that's not bigger than 30. We do T2, T5, T4, that's 18, that's not bigger than 30. So this is our critical path, our maximal path, and this is our critical time, which is 30. So we don't know if this is optimal or not, because we had 39 instead of 30. So we want to find the finishing time when one processor is assigned the task in the critical path and then the other processor picks up the slack. So let's erase this. So we have room to put our new processor. Alright, first processor, all we're going to do is put T3 for 8, T4 for 7, so that takes you out to 15, T5, which is 6, takes us to 21, T6, which takes us to 26, and T7 takes us to 30. T1 and T2 are both ready at the beginning, so we could schedule those. T1 for a weight of 10, T2 for a weight of 9, and here's our schedule. That's part C. Okay, for the critical path, what you're going to do is list all the maximal paths and the isolated vertices. So make sure you include those isolated vertices. Find the greatest of all the weights in the maximal path and the isolated vertices. If it belongs to a maximal path, the task at the head of that path goes next on the priority list. If it's an isolated vertex, then that goes next on the priority list. Then you're going to remove those tasks that you selected in that step, and then you're going to repeat the process. So to create a critical path priority list, we're going to list all of the maximal paths. So T6, T7, T8, T9. So that's 7 plus 6 plus 5 plus 4 is 22. Then we have T1, T5, T7, T8, and T9. So that's 8 plus 10 plus 6 plus 5 plus 4, which is 33. Then we have T1, T5, T3, T8, and T9. So that's 8 plus 10 plus 9 plus 5 plus 4 is 36. Then we have T1, T5, T3, T4, and that's 8 plus 10 plus 9 plus 11 is 38. Then we have T2, T5, T7, T8, T9, is 37. T2, T5, T3, T8, T9, which is 40, and T2, T5, T3, T4 is 42. Alright, so we look for the critical path, which is the last one that we found, had a weight of 42. And we're going to put on our priority list the head of that path, which is T2. Then we're going to go to each path that has a T2, and we're going to remove T2. Alright, so T2 was the length of 12, so now we're down to 25 here. $30 here, and 28 here. Then if we look again, 38 is the largest. The head of that is T1. So T1 goes next on our list. So everywhere we have a T1, we want to eliminate T1. T1 had a length of 8. So that brings us down to 25, 28, and 30. Now we look again. 30 is my largest, and it's T5, T3, T4. Both of my 30s are T5, T3, T4. So what I'm going to do is I'm just going to get rid of this one because it's a duplicate. So T5 is going to be next on my list. And I'm going to go through, and wherever I see T5, I'm going to eliminate it. Which is almost everywhere. T5 has a weight of 10, so that brings us down to 15. This is 18. This one is 18. This one is 15, and this one is 20. So now the largest is 22, so that puts T6 on our list. So everywhere we have T6, we eliminate it. It has a weight of 7, so that brings us down to 15. Now the largest I see now is 20, so T3 is next on our list. Okay, again we have a repeat. T8, T9 matches the T8, T9 up here, so I just got rid of that one. Now 15 is the largest, and they're all 7, 8, 9s. So I don't need all of those. Can get rid of that one. And get rid of that one. So T7 is next on my list. So if I get rid of T7, length of 6, that brings me down to 9. Then I have 9s and 11. 11 is largest, so T4. And then what's left is T8, T9. And that's the critical path priority list. Going to see if I can make this one a little neater. So what I'm going to do is I'm going to a white screen for this. So you'll have to follow along with your graph. So a white screen. I'm going to write out all of my maximal paths. T1, T2, T3, T9, T10. Next one, T4, T5, T9, T10, then T6, T7, T9, T10, and then T8, T9, and T10. See if I can clean up some of those crazy stray marks. Okay, so this was T8, T9, and T10. Alright, so add those together. The top one, 10 plus 5 plus 30 plus 8 plus 30 is 83. Plus 10 plus 8 plus 30 is 58. Two plus 6 plus 8 plus 30 is 46. And then 7 plus 8 plus 30 is 45. Alright, largest here is 83, so T1 goes on the list. So we remove 10 because that's the weight of T1, leaves us with 73. 73 is still the largest, so we remove T2. And T2 had a weight of 5. That brought us down to 68. 68 is still the largest, so T3 is next on the list. T3 has a weight of 30, so that brings us to 38. Now 58 is the largest. T4 is removed from the list. Has a weight of 10, so that brings us down to 48. 48 is still the largest, so that's T5. T5 has a weight of 10, so I'll remove that. 46 is now the largest, so I'll remove T6. T6 has a weight of 2, that brings us down to 44. 45 is now the largest, so that's T8. T8 has a weight of 7, that brings us to 38. 44 is now our largest, so T7 goes on the list. Removing T7, a weight of 6, that takes you to 38. Notice all of these are 38s and they all say T9, T10. So to finish out the critical path priority list, we just add T9 and T10. Okay, what I think I'll do is cut here because it seems to be getting a little long, and pick up on the scheduling algorithm in the next section.